So this is the last lesson of trigonometry. Doing really well to stay on schedule, which is great. Now we get to put everything we know into practice. So we're solving equations, which will take our identity work, plus our unit circle work, plus our calculator work. What don't I like about the first one? What I don't like about the first one is I have two different terms, a cosine squared term and a sine term. But I've come to know that cosine squared and sine squared have a relationship. Sine squared theta plus cos squared theta is equal to 1. So I can replace my cos squared theta with 1 minus sine squared theta, or x, plus 3 sine x. And that'll be equal to 0. A little bit of multiply notes, and I'm going to slide down a little bit. 2 minus 2 sine squared x plus 3 sine x equals 0. Write it in a better format, and maybe even make the sine squared positive. So I'm going to move everything over to the right-hand side. So 0 equals 2 sine squared x minus 3 sine x minus 2. And now I'm looking to factor that. That's a skill from this unit. Two numbers that multiply for 4 and add for a -3. Those will be 2 sine squared x replacing minus 4 sine x plus 1 sine x minus 2. Factor out a 2 sine x. I'm left with sine x minus 2. I have to repeat that. Sine x, pardon me, sine x minus 2, and that's a plus 1. And now I'm left with two statements to solve, two factors to solve. 2 sine x plus 1 is equal to 0, or sine x minus 2 is equal to 0. Now, something that we've come to recognize already is the sine x minus 2 equal to 0 will not have a solution. So if I can drag myself down a little bit this way and solve those, sine x would be equal to 2, which doesn't happen. There's no solution. And then 2 sine x plus 1 is equal to 0, which makes sine x equal to -1/2. And that's minus 30 degrees, or minus pi over 6. X is minus pi over 6, or 30 degrees. I have to go from 0 to 2 pi, if memory serves me right. So I've got to find my answers with positive rotations, CAST. So I have to be in this quadrant, quadrant 4, but I have to be 11 pi over 6. Pardon me, 11 pi over 6 and 7 pi over 6. 11 pi over 6 and 7 pi over 6 would be my solutions. I'm looking at B and recognizing just how crazy it is. I actually have to use two identities, the addition identity and the subtraction identity for cosine. So when cosine has two angles added, it's cosine of the first. So cosine x times cosine of the second, cosine pi over 6. And then there's a minus sign. Minus sine of the first, sine of the second. That's one term. So that's just this. And then there's a minus sign. And I have to use the cosine subtraction rule, which is cosine x times cosine pi over 6 plus sine x sine pi over 6, and that's in brackets, so that's the blue, and this is supposed to be equal to 1. Well, what happens when that minus sign moves in? When that minus sign moves in, I'm going to get some signs that change. So when that minus sign moves in here, it changes the sign there, and it changes the sign there. And I'll have cosine x times cosine pi over 6 minus cosine x cosine pi over 6. That's going to cancel. So that's pretty good. These are identical. So that's going to cancel. But I'm going to have two of these terms of minus. I have minus sine x sine pi over 6, but I'll actually have two of them. So minus 2 sine x sine pi over 6 is equal to 1. This actually works much nicer than I thought. I can evaluate the sine of pi over 6. That's a half. The half gets hit with the minus 2, and it becomes minus 1 sine x. And then I get to look at sine x being equal to negative 1. And from what we know of our unit circle or our graph of sine x, there's only one answer. And that's x equals 3 pi over 2. Let's try another one. So get used to walking around with your formula sheet. I've got sines and cosines. What can I replace, or what can I substitute for? I can substitute for cos 2x. Cos 2x, I can try this identity. Cos 2x is equal to 2 sine x cos x. And that's the one I'm going to try. So 4 minus 7 sine x is equal to 2 sine x cos x. So now I'm going to leave the 4 on the left-hand side, and I'm going to move the sine x over. So plus 7 sine x. Now I'm going to factor that sine x out. So sine x, and then I have 2 cosine x plus 7. But guess what? I can't solve this. I don't have an easy solution for solving for 4, so I need another alternative. What's my other alternative for subbing in for cosine 2x? It's kind of nice when something doesn't work. It lets you know that, hey, that's going to happen to you too. Cosine 2x is also equal to 1 minus 2 sine squared x. And that's going to be a nicer collection of work. So this one didn't work. I have to stop here. I might choose to erase. I might choose to paint it with whiteout, or just draw an X through it. But I have to restart. So I'm going to make my paper a little bit longer. So I have 4 minus 7 sine x. That's still living on the left-hand side. But on the right-hand side, I have 1 minus 2 sine squared x. My sine squared x is negative. That's not the greatest thing. So I'm going to make it positive by moving it over. So on the left-hand side, I'm going to add 2 sine squared x. My 7 sine x is still there. And there was a 4 living there, but that 4 is going to get affected by the 1, and it's going to go down to 3. So now I'm left with something I can factor, two numbers that multiply for 6, positive 6, but add for negative 7. What are those? And now I'm into factoring formats I feel pretty comfortable with, except that 7 should be a 6. So I can factor a 2 sine x out. 2 sine x, and I'm left with sine x minus 3. I have to repeat sine x minus 3, which is a minus 1. So 2 sine x, hard to remember that sign. 2 sine x minus 1 times sine x minus 3 is equal to 0. And we're used to this. This will be no solution. And 2 sine x minus 1, well, when does that happen? 2 sine x is equal to 1, x sine x is equal to a half, which happens at pi over 6. And pi over 6 in quadrant number 1, and the pi over 6 reference in quadrant number 2, which is 5 pi over 6. And remember, in this graph relationship, I'm looking for my general solution, so pi over 6 plus n pi, and 2 pi. The period is still 2 pi for this graph. And 5 pi over 6 plus 2 pi times n. One other quick comment to make. We're looking at the general idea of dividing by a trigonometric ratio. When is it okay to divide by a trigonometric ratio? In general, I would not. So in general, I would not divide by a trigonometric ratio. It turns out that on this side you can. On this side you can, because there is a point at which sine x is in fact equal to cosine x, and it doesn't happen when cosine x is 0. So here we have a situation where we know cosine x does not equal 0. So this student was okay in doing this work. They come up with a tan x statement that says tan x is equal to 1, and x would be pi over 4 in that situation, or 5 pi over 4 for going from 0 to 2 pi to flip into quadrant number 4. Here it's possible that cosine x is 0. Cosine x actually could be equal to 0. So no dividing allowed. No dividing allowed. What should you have done? This first step is nice, replacing it with an identity, but then what should have happened is the cosine x should have subtracted from the right-hand side to the left-hand side to be equal to 0. And then I can factor cosine x out. I'm left with 2 sine x minus 1 is equal to 0. So either cosine x equals 0, which was a possibility and we knew that, or 2 sine x minus 1 is equal to 0. And we've seen that solution a lot. That's it for trigonometric work. We're actually going to be working on trigonometry this entire week with a test coming up on Friday, but maybe this gives you a chance to work ahead, get into that practice test. And this can be finished off. Remember, sine x would be equal to a half, which happens at pi over 6, and 5 pi over 6. And cosine x equals 0 at 2 spots. What were they? So there are 4 possible solutions. So thank you very much. We'll see you over the course of this week for lots and lots of trigonometry.